Okay, the question in the video is, if V equals 10 volts, what value at R would limit I to 10 milliamps? Okay, so we're going to show the conversion of 10 milliamps to amps. So remember, when we're doing a conversion, we need to find three things. We need to find the unknown, we need to find the initial quantity, and we need to find the conversion factor. Okay, so our initial quantity, or sorry, our unknown, we want to convert. We don't know how many amps we have. So we don't know how many amps. Our initial quantity will be given in the question. Initial quantity is, oh, I guess I shouldn't write it as I. Maybe I'll just, because I looks like current, doesn't it? I'll write it as init to be a little bit faster. The initial quantity is 10 milliamps. 10 milliamps. And the conversion factor is given right here. There is 1000 milliamps per 1 amp, or you could write it as 1 amp per 1000 milliamps. Remember, it's okay to write a conversion factor right side up. It's okay to write a conversion factor upside down. Now, we're going to solve this. Our unknown is equal to our initial times our conversion factor. Okay, so our unknown is, we don't know how many amps. Our initial quantity is 10 milliamps. And remember, if you want to, you could put that over 1 so you have a top and a bottom to that number. Don't have to, though, as long as you keep everything that's on the top in the same line. Okay. Okay, so our initial is 10 milliamps, and our conversion factor, we either want to choose 1000 milliamps per amp, or we want to choose 1 amp per 1000 milliamps. And remember, we need our milliamps to cancel out because we don't want them in the end. We want to have amps. So if our milliamps are going to cancel out, I need to have them down on the bottom. So that's going to be, my milliamps are going to go here. And there are 1000 milliamps per 1 amp. So these guys will cancel out. 10 divided by 1000, that's going to be, that's the same as 1 over 100, which is 0.01 amps. Okay. Starting with the formula V equals I times R, use the 6-step method to show how to solve this question. Okay. So we want to know, oh, we need to write our given. So we are given the current is 0.01 amps. We have to use amps in the question. We can't use milliamps because that's just how the formula works. Okay. Volts is 10 volts. Okay, and we want to know what value of R. So we don't know what the resistance is, so that's, we don't know how many ohms. So we are starting with V is equal to I times R. Okay, that is our formula that we've started with. And we want to have R on its own, so we're going to divide both sides by R. What? No, we're not. I want R on its own, so I need to declutter it of the I. Oh, coffee. Must get coffee after this. Okay, and so now we have R is equal to V over I. So I'm going to rewrite it here. R is equal to V over I. And we have 10 volts is our voltage. So that's 10 volts over I, which is 0.01 amps. Okay, right. Okay, so this is 1000 ohms. Okay. when you double the voltage, what happens to the current? Well, remember that current is proportional to the voltage. So if you take the voltage and you multiply it by 2, the current is going to do exactly the same thing. It's going to multiply by 2. If you look at your formula, V is equal to I times R, or if we solve for I, okay, we have I is equal to V over R as voltage. If I was to multiply this by 2, in order for it to remain equal, this would also have to multiply by 2. Okay, in this example in the video, we have a 9-volt battery, and the LED will use up 3 volts. Remember that electrons start at the negative terminal of the battery with 9 volts, okay? So this is like if a ball starts at the top of the hill and it has 9 joules of energy, let's just say joules, okay? If there's a ball up here at the top of the hill, and it rolls down the hill, it has to lose, this ball must lose 9 joules of energy to get to 0 joules at the bottom. If it can only drop 3 volts over this LED, what does the resistor, how much voltage is dropped over the resistor? And well, that has to be whatever's left over, so it has to be 6 volts. Okay? How much voltage will the resistor use up? 6 volts. Which direction does conventional current flow? Now remember, conventional current, you were introduced to it earlier. It does come up in physics, in particular in the magnetism section. Conventional current is the opposite of electron flow. And remember, it's because those guys way back when, they didn't know what kind of particles were flowing. And they thought it was the positive particles that were moving. And they would move in the opposite direction to electrons. They would move towards negative and away from positive. So conventional current would be from positive to negative, because it was positive charges flowing. A positive charge would be repelled by the positive, and it would be attracted to the negative. Okay? However, we now know that it's not positive charges for flowing. We know it's the negative electrons. And so the electrons are repelled. If this is our battery, okay, and let's say we had our positive terminal here and our negative terminal here. The electrons would be repelled by the negative because negative repels negative. And the electrons in the wire would be attracted to the positive because positive attracts negative. Okay, so they would flow from negative to positive. Negative to positive. There we go. Okay, use dimensional analysis and the 6-step method to figure out what resistance the resistor in this problem should have. The video does not show all the steps. I want you to show all the steps. Okay, so we're going to do this together. Okay, so we have a current which is equal to 20 milliamps. We don't know the resistance, so that's going to be my unknown. That's going to be what I want to find. The resistance is, and the unit of resistance is the ohm, represented by the letter omega. And our voltage, remember our voltage, although the battery is 9 volts, 3 of those volts are being used up in the LEDs, so we need to know what the resistance is here. So this is going to be only 6 volts are used up in the resistor. Okay, so 6 volts are used in the resistor. Now, I'm going to do this over to the side here. So we have, well, I would really like to use Ohm's law, V equals I times R. But remember that I has to be in amps. I cannot be in milliamps. So the first thing I have to do is I have to convert milliamps into amps. So when we do a conversion, we have an unknown, and in this case, our unknown is the amps. We don't know how many amps. Our initial quantity is the milliamps. We have 20 milliamps. And our conversion factor, well, we were given it in the previous question. It was, there were 1,000 milliamps per amp. 1 amp is equal to 1,000 milliamps. So let's do that conversion. My unknown is equal to my initial times my conversion factor. So my unknown, we don't know how many amps, is equal to the initial quantity, 20 milliamps, times our conversion factor. Now, if I was to just write 1,000 milliamps per amp, all of a sudden I would get, well, what would cancel out? Amps would cancel out. I would end up with milli squared amps because I'd have milli times milliamps, and that's just not good, right? That's just a weird thing. So if you use unit conversion and you show your cancellation, you'll know if you've made a mistake. Okay, so the milliamps have to go on the bottom so that they can cancel, and my thing that I want to find needs to go on the top. So that's going to be 1,000 milliamps per 1 amp, because remember, this conversion factor can be written that way, or it can be written upside down like we did in the question. Okay, so 20 divided by 1,000, we're going to move our decimal place 1, 2, 3 places. That means I'm going to have 0.020 amps. So now everything that I need for this formula is in the correct units. So now we're going to say we are given, let's see, what does it say? If we increased the resistance in the question above, oh no. Oh, what resistance should this thing have? Well, we have 6 volts, right? 6 volts are used up over that resistor. So we're given V is equal to 6 volts. We are given I is 20 milliamps, which we now know is I is equal to 0.02 amps. 0.02 amps. And our resistance is our unknown in ohms. So let's take that formula, V equals I times R, and we're going to solve for R. So we need to declutter our R, divide both sides by I, boom, boom. Or you could have done V equals I times R, bring the I down, so you end up, in both cases, you end up with R is equal to V over I. Voltage. Voltage is 6 volts. Current is 0.02 amps. Okay, and we're going to end up with 6 divided by 2 is 3. And now I just need to figure out where I need to put my decimals. So I have 2 times 10 to the negative 2. So that would be, so I have 1 over 2 times 10 to the negative 2. So if I bring this up into the top, that becomes 10 to the positive 2. And so I have 3 times 10 to the 2, which is 300. Don't worry about that. You can just plug it into your calculator. And the unit is the ohm. Okay, so we ended up with 300 ohms, and oh my gosh, what did I forget to do? I forgot to box my final answer. Did I forget to do it up here somewhere? I feel like I did. Uh-oh. Let's go look. Somewhere here. Look at that. My final answer here was 1,000 ohms, and I didn't box it. Don't forget to box that final answer. Don't be like Miss Spence. Okay. If you increase the resistance of the bulb in the question above, what happens to the amount of current? Well, if you increase the resistance, the current will go down. And if the current goes down, the brightness of the bulb will decrease. Decreases. And I'm going to leave the review for you to do, and I will just post that as an answer key.